Hi, today we're going to look at the I can statement. I can express whole numbers as fractions. Let's see if you can learn how to do this by the end of the lesson. Right here we have a circle that has been partitioned into 4 equal parts. So I know my denominator is going to be 4. 4 of those areas are shaded. So 4 parts are shaded, so my numerator will be 4. But when we look at it, we can tell that it's actually the whole shape that has been shaded. So one whole. So we know that 4 over 4, or 4/4, is the same as one whole. How would that look on a number line? Well, we would take a number line and label it 0 to 1 and partition it into 4 equal parts. So I will split it in half again, and in half again. So I have 1, 2, 3, 4 intervals. My first endpoint would be labeled 0/4, 1/4, 2/4, 3/4, and 4/4, which means I have hopped 1, 2, 3, 4 out of the 4 hops. Does that make sense? Let's look at another one. Here we have 2 circles, or 2 shapes. Both of them have been partitioned the exact same way. This one has been partitioned into 4 equal parts, and this one has been partitioned into 4 equal parts. 4 of these parts have been shaded, so our numerator will be 4, and 4 of these parts have been shaded, 4 out of 4. What happens if we add those together? We actually have 8 parts shaded out of a total of 4 parts. So our fraction would look like this, 8/4. Now if you remember from our last lesson, I said that if the numerator is greater, it means it's more than 1. And in this case, it's actually 2. How could I prove that on a number line? So we have a number line, and I don't know where we're going to end up. So I'm going to keep the end open, and I'm just going to start here at 0. Now I know I need to partition it into fourths, so I'm going to start there. I'm going to call this 1, or 4/4, and I'm going to partition this in half and in half again, so that I have 1, 2, 3, 4 sections. Okay, so this would be my 1/4, my 2/4, my 3/4, and my 4/4. But now I'm not done. If you remember, my original fraction is 8/4, so I need to keep going. But I will keep going, partitioning exactly the same. Just like my circles are partitioned the same, my number line must be partitioned the same. So I'm going to try and keep the same interval and keep going until I get to my target, which was 8/4. So let's keep going. So we have 3/4, 4/4. This would be 5/4, 6/4, 7/4, and 8/4. And 8/4 is actually the same as 2, right? Just like we have these 2 shapes here. And I'm going to give you a trick. If you take 8 and divide it into 4 equal parts, 8 divided by 4 is 2. That's how you know that the whole number is 2. Let's keep going. For these 3 circles, they're still partitioned into fourths. But how much is the shaded area worth? Well, we know 4 plus 4 plus 4, or 4 times 3, is 12. So our numerator is 12. So 12/4 is one way we could represent this fraction, okay? But there's another way. We could just say that it's 3, right? It's 3 whole parts. But if I wanted you to make it a fraction, there's one easy way I could do it. I could put it over the denominator of 1. Why do you ask? Well, instead of looking at each shape as fourths, I could look at each shape as 1. This is 1, this is 1, and this is 1. And I have 3 of them. kind of just like when you're looking at a set, okay? So 3 of the shapes, but there's only one type of shape. So we could say 3 over 1. Well, what if I changed and just wrote this, 4 over 1? What do you think the number actually is? It's actually 4, okay? It could be having 4 whole squares, okay? If you have any questions, don't forget to see your teacher. Thanks.